So a grid is superimposed over a scale drawing of a town. My house is at the point H, which is 3, 1.2, and school is at S, which is 6.6, 6. Find the shortest distance between those points. All right, so I'm just going to graph this on this grid. So if we draw a normal diagram, a normal Cartesian plane, where we have the x and y axes. So 1.2 will be 3 units across, 1.2 up, which is going to be about here. And then 6.66 will be 6.6 units to the right, and then 6 units up. So we can say that's about there. Now, there are many different ways you can go from H to S, which is what the question's asking us. You can go around here like here, you can go even like this, and then finally end up here. But the quickest way of doing it is just going in a straight line to it. So we're just going to have to find the length of that straight line. Now, the way we can do that, so let me just write the coordinates. So this is 6.66, and this is 3, 1.2. So there is a formula for the distance, and the distance is equal to the square root of the change in x squared plus change in y squared. Now, the reason I say that is because it's the number of units, because if you make this a triangle, so I'm just going to, so you might recognize this as the Pythagorean theorem. So the reason why we can say that this is the Pythagorean theorem is because if you imagine a line like this is a right angle, we can say that this distance over here is the change in x, because it's this x value minus this x value, and this going up over here is the change in y, because it's this value subtracted from this value. And then, as we know by Pythagorean, in a right angle triangle, this squared plus this squared is going to equal the hypotenuse, which is what we want. And if we square root that, we get the distance. So I'm going to label this part over here D. So now we just need to find the changes. So the square root of the change in x, so it's 6.6, which is the x coordinate over here, minus 3, 6.6 minus 3, all squared, plus the change in y, which is 6 minus 1.2. So that's 6 minus 1.2 squared, which gives us the square root of, 3.6 squared plus 4.8 squared. And this gives us the square root of, well, when we add up 3.6 squared and 4.8 squared, this gives us the square root of 36. And this gives us D equals 6. So what that means is the shortest distance is equal to 6, not 6 kilometers, 6 units on this diagram. So actually over here, this step, you do not need a you do need a calculator. I didn't do that in my head. I used a calculator to do that. So let's move on to the next part. So we are told that the scale factor for the drawing is 1 unit is equal to 1.25 km. Find the real shortest distance between those points. All right, this is fairly easy. So we established the shortest distance is 6 units. Let's just write that 1 unit is equal to 1.25 km. And we know 6 units is the distance. So if we go from 1 unit to 6 units, that's multiplied by 6. That also means that this 1.25 km must multiply by 6. So we're going to get 1.25 times 6 as the real shortest distance. So 1.25 times 6 is the same as 6 times 5 over 4, which is 30 over 4, and that's equal to 7.5 km, 7.5 km. And that's the real shortest distance between those points. So you can see the distance formula has been derived from the Pythagorean Pythagoras theorem. And it's just important to be able to recognize that application.